A study showed that the mean duration of a certain strain of flu virus was 12 days with a standard deviation of 3 days. If the data is normally distributed and you caught this strain of flu virus, determine the probability to the nearest hundredth that it would last longer than 17 days or between 13 and 15 days. Well, let's start with the first one. Keep in mind, of course, the mean is going to be 12 with a standard deviation of 3. So longer than 17 days, that's probably going to be somewhere around here. And we want the shaded part because it is longer than 17 days, and the shaded part is going to be to the right of it. All right, we want to find this area right here. So first off, we need to find a z-score for 17. So in that case, 17 minus your mean, which is 12, all divided by the standard deviation of 3 days. In that case, the z-score is going to be 1.67. So that corresponds to an area of 0.9525 in your z-score tables. However, keep in mind that this is everything to the left of that z-score. So that's everything I've highlighted here in blue. It's not what I've highlighted there in black. Okay, so in order to figure out that area in black, you have to keep in mind that the entire area underneath the curve is equal to 1. So what we're going to do is we're going to subtract that blue stuff. So it's going to be 1 minus 0.9525. And in that case, what you're going to get is a probability to the nearest hundredth of about 0.05. That is the black shaded part. Next up, we want to know the probability that you'll be getting the flu between 13 and 15 days. Both of those are above the mean of 12, so it's in between this area right here, with the lower end being 13 and the higher end being 15. Now, of course, before we do anything, what we need to do is find z-scores. For 13, it's going to be, we'll call that z1. It'll be 13 minus 12 all over 3. 3 being the standard deviation. In that case, you're going to have 0.33 as a z-score. For 15, it's actually not that bad to figure that one out. If you think about it, that's actually going to be 1 standard deviation. But we'll do it the long way just to show you that. It's going to be 15 minus 12, all divided by 3. Well, 15 minus 12 is 3. 3 divided by 3 is just going to be 1, or 1.00. When you find those in your z-score tables, well, it's going to be the area of 1.0, and you're going to minus out the area of the z1, which is going to be 0.33. That's the z-score for that. The reason being is because, of course, both of these reference the area to the entire left. In this case, we don't want this part here that I'm shading in red. All we want is the part shaded in black. So you're going to get the area that's entirely to the left of the z-score of 1, and you're going to minus out that area to the left of the z-score of 0.33, because we don't need that. Okay, so the area to the left of the z-score of 1 is going to be 0.8413, and you're going to minus out the area to the left of 0.33, which is going to be 0.6293. Okay, and when you work that one out, you're going to have a probability to the nearest hundredth of 0.21. You have 0.21 probability of getting the flu between 13 and 15 days. That's about 21% chance.